Hey everyone, welcome to today's Explainer, where we're unpacking something incredibly fascinating, the actual day-to-day routine of a working scientist. We're stepping way beyond abstract math and theories and heading straight into the halls of Oxford University to follow Dr. Becky, a real-world astrophysicist, from morning until night.
It's a question that sparks so much curiosity, isn't it? What does an astrophysicist actually do all day long? I mean, when we picture an astronomer, the pop culture image is almost always someone bundled up in a freezing dome, squinting through a giant telescope lens in the dead of night. But the reality of trying to answer questions that literally no one on Earth knows the answer to yet, it's way more dynamic, and honestly, a whole lot more relatable than you might think.
Okay, let's dive into this map of a typical Thursday for Dr. Becky at Oxford. We're looking at a nicely structured routine: morning coding, midday seminars, and a little radio time, afternoon data analysis, and finally capping it all off with some classic evening Oxford traditions.
Kicking things off with Section 1, Morning, Data, and Discipline.
Now, the unglamorous but absolutely vital reality of modern astrophysics starts right here. Turns out, it's less about staring at the night sky and much more about staring at computer screens. But before any of that science happens, you need fuel. And breaking the stereotypical scientist mold right out of the gate, Dr. Becky doesn't even drink tea or coffee. Nope. Her morning fuel of choice is hot squash. Now, if you're not familiar, it's basically a concentrated apple and blackcurrant fruit juice, but served piping hot. It's just this fun, humanizing little detail that reminds us that behind every massive cosmic theory is just a normal person with their own quirky morning habits, probably just trying to warm up in a chilly office.
2 months. Check this out. Dr. Becky starts every single morning by writing out a to-do list in her bullet journal. And this isn't just some casual, trendy hobby for her. This exact level of strict daily organization kept her focused enough to write her entire PhD thesis in just 2 months. It's a massive testament to how crucial personal discipline really is when you're managing complex, long-term research goals.
Next on her agenda is checking the archive preprint server. This is an absolutely critical daily email archive. It provides free, early access to the very latest astronomy journal articles, right before they hit official publication. Dr. Becky scans the abstracts, basically the summaries, and the figures every single morning. It's exactly how scientists keep their finger on the pulse of global research day in and day out.
But this daily check often highlights the extremely frustrating reality of research. For example, Dr. Becky was testing a hypothesis that non-rotating galaxies contain less hydrogen gas. She started out with a really solid sample of 200 galaxies, but when she matched that against some new survey data, that initial 200 shrank down to 40. And out of those 40, only 3 were the non-rotating galaxies she actually needed to study. Just 3. It completely destroyed her statistical significance. It's a perfect, real-world example of how science requires immense patience. Sometimes you literally just have to sit back and wait months or even years for better data to come along.
So, what's her absolute top advice for aspiring scientists? Learn to code. Seriously. Dr. Becky uses a custom program she actually wrote herself, which she playfully named Snitch, to model star formation. Modern astrophysics relies incredibly heavily on coding languages like Python and Jupyter notebooks. You simply cannot do this kind of heavy data science with massive samples in a basic spreadsheet. Coding is, without a doubt, the fundamental language of modern astronomy.
Moving right along to Section 2, Midday, Collaboration, and Communication.
Right around 11 a.m., all that solitary coding stops, and the highly social nature of the Oxford Physics Department really kicks into gear. It's so fascinating to contrast 2 entirely different scales of studying the exact same objects during these midday seminars. While listening to the renowned physicist Heino Falke, we learned that Dr. Becky studies the macro scale, meaning how supermassive black holes affect the entire galaxy they live in. Meanwhile, Heino focuses on the microscale, literally modeling the material flowing directly into the event horizon. It just goes to show how massive the field is. You absolutely need experts zooming all the way in and zooming all the way out, just to get the full picture of the universe.
But you know, communication isn't just for chatting with other experts. Midday also involves a quick bus ride down to BBC Radio Oxford. Dr. Becky regularly sits down with presenter Lily Mitchell to explain major concepts to the public, like the current cosmology crisis, which is the wild fact that our data on the actual age of the universe just isn't matching up right now. And this is vital work. As she points out, taxpayers partly fund this research, so scientists have a profound duty to communicate their findings back out to the world and keep people engaged with the cosmos.
Next up, Section 3, Afternoon and the Scientific Grind.
Okay, so the glamour of the radio studio fades, and it's right back to the office to tackle the everyday hurdles of academia.
The daily scientific grind is actually full of these totally relatable, contrasting human moments. Things like dropping a phone while filming and blaming damn gravity, or procrastinating by watching the Dragon Edgar Christmas advert, applying cuticle oil at her desk, or just clipping videos for Twitter. It is so incredibly easy to put scientists up on this unapproachable pedestal, but ultimately, they're just ordinary people managing their cuticles and their Twitter feeds while trying to unlock the deepest secrets of the universe. A huge cornerstone of the afternoon is the Journal Club. Here, Dr. Becky meets up with her PhD student Tobias and Professor Chris. Each one brings a different paper to the table. Maybe one on black hole feedback, another on star formation in dense environments, and one on a really unique Milky Way star. And the reason they do this? Because no single person can be an expert on absolutely everything. By debating the latest discoveries together, they cross-pollinate their ideas and figure out exactly what their next big research question needs to be.
And all of this daily work feeds directly into the broader life cycle of astronomy research worldwide. Think about it. You get a spark of an idea from a journal club, you apply for time on a massive telescope down in Chile or Hawaii. If you get approved, you observe. Then you spend months analyzing that data. Finally, you publish your findings. And then, the whole cycle repeats the second someone else reads your paper in their own journal club. It is this really beautiful, self-sustaining loop of human discovery.
Finally, we hit Section 4, Evening, Outreach, and Tradition. As the sun sets, the sheer incredible scale of this science really comes into focus. The evening kicks off with a massive public lecture covering a truly mind-bending concept, space interferometry. Basically, this involves combining data from telescopes scattered all across the Earth to create one giant virtual telescope with a diameter as large as our entire planet. It's exactly how they managed to capture that famous image of the supermassive black hole in galaxy M87. And get this, they are even planning to extend these telescopes into space or literally onto the moon to make the effective lens even larger. How wild is that?
And the result of all that groundbreaking technology? 4.5 billion. Let that number sink in for a second. 4.5 billion people globally saw that famous black hole image from M87. Over half the world's population connected with a single piece of astrophysical research. It is a staggering statistic that just perfectly highlights the unifying power of science communication and exactly why public lectures like the one Dr. Becky attended are so incredibly essential.
The day concludes with a well-earned dinner to celebrate the guest speaker. But this isn't just your standard dinner out. This is at Christ Church College, founded by King Henry VIII, featuring the exact same stairs and balcony used as Hogwarts in the Harry Potter films. Dining in the historic McKenna Room, right beneath a massive portrait of Queen Elizabeth, really highlights the deep, familial community of academics. It is this totally magical atmosphere, steeped in literally centuries of intellectual history. So, from sipping hot squash and debugging Python code, to broadcasting to the public and dining in the halls of Hogwarts, a day in the life of an astrophysicist is a rich, multifaceted journey. It takes immense patience, constant collaboration, and just a boundless sense of curiosity. So, as we wrap up this explainer, I want to leave you with this thought. The universe is completely packed with unanswered questions. So, what mystery will you solve today? Keep learning, keep questioning, and I'll catch you in the next explainer.